So we're looking at page 4. And they might not, they're going to have you draw a slope field, I guarantee it. They might also have us go multiple choice on it. So check this out. They're saying which of these fingerprints, snowstorms, matches this differential equation. All we've got to do is we've got to it's like a guess and check. What'd you say? Let's go look at some trends. Let's go look real fast. You guys, would you agree in this answer A? In answer A, in quadrant 1, are all these slopes positive?
Yes.
Okay, what about quadrant B? They're all negative over here? Positive. Over here. Positive. So let's go pick a point in quadrant 1. Or what do we know in quadrant 1? All my X's and my Y's are what? Positives, right? If I put a positive X here and a positive Y here, would my answer be positive? Yeah, right? So if I put anything in the first quadrant, if I put the point 1, 1 or 2, 2 or anything in the first quadrant, that would get me a positive answer. So I'm looking for a slope field that has all positive slopes here. Would you agree that which one's out?
B.
It's out. It's not B. I like that, Hilo. It's not B.
It's 100% D.
You're thinking it's D?
Yes.
Why?
Because any X values that are negative will be positive because of the square.
Ooh, I like that thought process. That he's like,
Do they all check what we're basing?
agreed. Let's back this up a little, real fast. What would we say? Let's go pick up actual point. You're right. Your logic is perfect. It's good. If we tried -2, I'm down with that. Ooh, but look, not. Because -2, aren't these slopes negative here?
We get positive.
That's a positive.
See, I thought that was to like 10.
So you're saying when Y is positive and X is negative, let's get an actual value.
-3, 2.
Well, -3, -2 would be over here.
Look at the
Oh, we're looking at the fourth quadrant?
I thought that's what you said it was dependent on, right? The fourth quadrant? Or the third quadrant? Second quadrant, my bad. Okay, let's pick an actual point there. What if we chose the point like -1? What if we looked right here? -1, 0. What's the slope at that actual point?
1.
Well, in this picture, isn't that a negative slope?
Yeah.
What about in this picture? Negative. What about in this picture? It's positive. So if I actually plugged in that point, -1, 0, to this equation, like you're saying, that squaring the X is going to make it positive, plus 0, that gets me a 1. The only one that has that positive slope is D.
Let's go.
The nuisance of these is it is some guess and check. If you can see trends like that, stick with that. If you're more of a point picker, stick with that. Sound good? This, they flipped it. Now they just gave us one graph, 4 equations. Whew. Again, it could be some guess and check. You guys, I want you to know when they've got this going on here, that this is actually referring to a horizontal asymptote right there. Whoa.
My favorite.
Okay. Y'all want to pick a point? Let's pick a point.
0, 4.
0, 4 is going to have a slope of
0.
0. Okay. Let's see if any of these would give us a slope of 0. If I use the point 0, 4, we need a slope of 0. If I plugged in a 0 here and a 4 there, what would I get?
0.
0. So A is still in the running. What about B? 0, 4. Wouldn't that get me a 0? Because 4 minus 4, B is in. Wah, wah. If my Y is 4, isn't it going to get me 0 for all of them?
That's so dumb.
That is dumb, but that is part of it. It's like a guess and check game. So let's not pick that guy.
Pick that point, Graham.
What if we just pick like?
What if we went -2, 2? Now, am I positive exactly where that slope field is? I'm not, but I'm sure that all those slopes around there are what? Are positive. So we're saying at -2, 2, my slope is positive. At -2, 2, my slope has to be positive. I don't even care what the value is. When you plug in a -2 and a 2, does this get me a positive or a negative?
Negative.
It's going to get me a negative, right? So we don't like that. What about B?
B works.
B gets me a positive still. Doing it. How about C? That'd get me a negative slope, so C is out.
Try something with a -1.
D
Would get you what's in.
is going to get me a positive. So B and D are still in. Talk to me.
Because the y squared.
He's saying, oh, that y is squared here and the y is not there. So if we had a negative y, that's the only thing that's going to change it, right? Negative y's are going to happen in both the third and fourth quadrant. Give me a point you want to pick. One negative one is what I heard. One negative one is going to be somewhere around here. I don't know, but it's going to be what?
Positive.
Should be positive. Which one is going to give me a positive value? D. Healed. Perfect. Squaring that negative is going to make it positive. Awesome. On page 5, you guys, they also might give you 2 points for, they might give you the slope field in a free response and have you sketch it. Sketch the curve that follows the trend. So look what this says. They gave you the slope field. Go sketch the curve, sketch the solution that passes through 2, -2. Let's start with that. Do you guys agree 2, -2 on my graph is right there? What's the trend around that? Yeah, so you guys, we just say, ooh, those are all slopes of 0. Love that. They're looking for that.
Can you sketch it right on this graph?
Right. Nope, they want it right on that graph. Then they also want us to sketch the solution that passes through 3, 4. 3, 4, they're going to label them typically with a point like they did. This is going to be uncomfortable for us today. We just want to follow the trend. Exactly, Graham. You're like, okay, if I'm kind of following, these are positive slopes and they're going up. And then if I'm following, these are like, they go down and then they kind of go over and then I'm following those.
Do you just stay on the line?
No. So we're looking for a trend. If Collins looks like my blue one and he's like, I went lower and I went more narrow, great. Did you still follow the trend? Awesome. If Graham's like, oh, I went crazy and I went a little shallower, it doesn't matter. They're good with that shape. You followed the trend. Did we end? These are very big negative slopes. At some point, we got to go from a negative to a positive. So we got to have a slope of 0 at some point, and then we got to follow up. None of ours are going to match, and that's fine. What they don't want you to do is like a graph like mine. They don't want you to be like, They don't want that. Just give yourself one fell swoop. Sound good? All right, here we go. Let's skip that guy. Let's go this one. Good old AP test question. You got this. I'm going to give you 3 minutes. So what was kind of your deal maker to pick D on this one?
Because it was a steeper slope.
Ooh, steeper slope. I like that. Third quadrant helped too.
I did the first and fourth.
I did first and fourth.
I love it. Everyone's got different processes, and that works. If I went anywhere in this third quadrant, and any negative x, any negative y, it's going to be a positive slope. I'm sorry, that's a negative slope. That's a negative slope. So a negative and a negative times a negative is a positive times that negative. You guys, why is it not B?
Because the negative's out front. So
I just did, I did the point 3, -3.
3, -3 needs to be positive, right?
And not 1. Just because that's steep.
Too steep. You're saying you're looking at the steepness. Agreed. Okay. Is there a way that we could not have it be positive, though? I'm nervous if we still pick -2, -2. If I chose that, that'd be a negative. But that would still be negative here.
Negative 3, -3.
You can just check for the zeros.
The zeros, Lila. Talk to me.
So to start it off, you can just find whatever makes the function 0. For C and D, y or x makes it equal 0. But for A and B, x makes it equal 0, but y makes it undefined. There's no undefined points on this graph.
Right, because an undefined slope would be the vertical tangent lines, right? So this slope here, when y is 0, my slopes have to be 0. What if I put in the point, say 3, 0 right here? 3, 0, wouldn't that be -3 over 0, which is undefined because that's a vertical line. So these would need to be verticals. Now, your little steepness logic was fine, but if we wanted to go more algebraic, then we would show that. Okay, you guys, we're on page 6. Let's just remind ourselves, we're going to bounce around a little bit. I want to start with this one, number 2, because I want to just look at drawing another slope field. Let's just practice it. Anywhere there's a dot is where they want a slope. So where might we start? 0, 0, sure. It'd be 1 over 0.
So anything on that Y.
Undefined. Well, this one's going to be undefined. It's going to be a vertical. Gross.
Thing that it's gonna be
Oh, but where?
like horizontal.
With a Y.
zero.
Agreed. So, if my y's are 0, we'd be dividing by 0. If my y's are 0, we'd have vertical slopes. Agreed.
The X is -1.
Ooh, he says at -1, say 1. If my x was -1, what would we have for our slope? Excuse me, there. Very good. We'd have a 0 over 1, which is 0. And anytime my x is -1, we'd have a slope of 0. Right? Like -1, 2. We'd still have a slope of 0.
To show, like, do you have to show those?
No, this is not needed ever. They're only going to give you points for this. Yeah. You're right. They're never going to give us one that we have to draw that's vertical. So this is from an AP classroom one. They're never going to have us draw a vertical. They're never going to make us be in the situation on the test. So I apologize about that. We shouldn't have had to do that. So I'm okay. Theirs, honestly, would not have had dots here. They would not have had dots right there. Yeah, good call, Care Bear. Because 0 over 0, that's not even undefined. It's like an indeterminate form, right? Like, ugh, good call. So I'm kind of good with getting rid of those dots if we want. Good observation, Carita. We got some other points that we're looking for. You go ahead and fill in again. You write out what helps you. Maybe it doesn't help you to write them out. 0, 1. I got a slope of 1. Anyone else get that?
It doesn't matter how you angle. Okay.
0, 2. I'm going to say half. 0, -1. You checking with mine, Nels? 1, 1.
Does it matter if like how steep we draw the slope, like as long as it's like positive?
Exactly. I mean, I like to different that this is a slope of 1 and that's a slope of 2. I'm going to get a little steeper. Do we have to be more accurate than that? Not at all.
Okay.
Do we get the slope over here was 1?
Yeah.
I got it just 3 over 2.
1, 2. My x is 1. My y is 2.
Oh yeah, no, I did. I mixed it up.
1, -1. I know sometimes that's why it helps me to write it out. It's very simple math, but sometimes it's a lot to do in our head. Is that going to give me a -1 here? X is 1, so that'd be 2. That'd be a -2? Guys, you're good. You are good. Boop. Okay, so this is the new thing. This is something new. Part B for this question. The slope field above is drawn only at 12 points. For us, really 9. It's defined but it's defined like a slope field exists everywhere. We only had to draw these 9 points though. Describe all the points, not just these ones, where the slope is -1. You guys do agree they gave us dy dx. They're saying when does dy dx equal -1? Could I set those equal to one another? Yeah, because this is a dy dx and this is a dy dx. Let's go set them equal to one another. So I'm just going to say, when does x plus 1 over y equal -1? When they say describe all the points, guys, all they want you to do is just get y by itself. All they want you to do is get y. You cool, Stevie? You're in the zone. So let's go multiply by y. And we get x plus 1 is -y. What would my y values be? Exactly. And what that's saying, Daria, is you're saying whenever my y values are -x minus 1, my slope will be equal to -1. When they describe all the points, when they say describe, this is you describing it. Whenever my y's are equal to -x minus 1, we Gucci. Sound good? How I want to look at this first one, you guys, is not necessarily as much of this part is can we sketch it. Let's go choose a point. You with me, Seamus? They're going to give you a point on the, oh yeah, they did give us a point. 0, 1. They didn't ask for us to sketch it. I want us to practice sketching it. 0, 1 is right here. Give yourself a point. Boop, there's 0, 1. I want you to try to sketch what that slope field would look like. Follow those trends. Often when I do it, I kind of like did it like this with little,
I think it's a cosine, right?
Yeah, potentially.
So it's not.
So we're going to kind of follow those trends.
Doesn't it go up and down at 3 1 interval?
Mm-hmm.
That's
Let's go see. Do you agree? So they're saying which function could this represent? What's an x squared graph look like? Negative x squared? Plus 1? Does it have that was so good. You guys are trained so well. Does it have a horizontal asymptote anywhere? No. So we're not digging B.
My God.
Anyone know maybe science has helped you? What does an exponentially increasing function look like? Whoosh. It's going to go whoosh, exponentially increase. Is this doing it?
No.
No. The derivative of this, the derivative of arctan is that, but interesting. Hold on, back it up. Why is it not cosine? Cosine doesn't have a horizontal asymptote like that. Yeah, cosine's going to be cyclical. So it is going to be 1 plus 1 over x squared. Again, I'm not worried about this as much as just practice sketching. Last question. You guys, let's sketch it.
Come on.
I'm not giving you a point here, but what is that sketch going to look like? What's that
Reverse
trend?
E.
She's like, is it kind of doing this?
Yeah.
Yeah. He's like, is it kind of going like this, up and over?
I believe it is natural log.
Why isn't it x squared?
That's
That's not a u, right?
It's not going up.
E to the x is exponentially increasing. You guys, if this is e to the x, here's e to the negative x.
Yeah, wrong.
Wrong.
Get out of here. It's not cosine.
It's not cosine because we're not going sinusoidal. It is a natural log. Let me just remind you what a natural log looks like. Boop. Here is a natural log graph.
It's not like,